Okay, chapter 14, day 3. What we're going to focus on today is how do we find sides and angles of non-right triangles. Okay, so isn't that what we did on day 1 and day 2? And the difference is today you're going to be given some different information. So, for example, let's take a look at this triangle. We have a couple angles, we have one side, we have a side that we're trying to find, okay? Solve for x to the nearest tenth. Well, if I look at the information that I have, since we don't have enough information for the law of cosines, we have to use something different. If I had this other side, then I could use the law of cosines. But because I don't, we're going to have to use something different. And what we're going to use today is called the law of sines. Now, depending on the information given, usually you can use either the law of cosines or the law of sines. Rarely can you use both. And if you're unsure which one to use, try setting up one of the formulas. And if you don't have enough information to fill in the formula, then you have to use the other one. So the law of sines says that side A, because this little a is a side, okay? That right there is a side. Side A over the sine of angle A equals side B over the sine of angle B. It's a proportion, okay? So notice lowercase letters are the sides, uppercase letters are the angles. So side A, which is across from A, over the sine of angle A equals side B over the sine of angle B. And the formula actually says side C or over the sine of angle C. I don't want you to get hung up on the letters. You know, what if I didn't use letters A, B, and C? So let's think of it this way. This is a side, okay? This here, that's the angle across from the side. So there's a side, and this is the angle across from the side. This is the angle across from the side. So here's the side, here's the angle across from the side. Here's the side, here's the angle across from the side. So if I was to set up this for this problem, I would say x over sine 20 equals 12 over sine 45. The side and then the sine of the angle across from it. Okay? Let's take a look at putting this into action. All right. So here's a problem. Solve for x to the nearest hundredth. Okay? So set up a proportion. The first thing you have to do. All right? Now, I have 5.4 over sine 27. Here's a side and an angle across from it. Here's a side, but this angle is not across from it. I have to use this angle. Sometimes the angle is given to you. Sometimes you just got to use a little bit of triangle math to figure it out. So 80 plus 27 is 107. 180 minus 107. 180 minus 107 is 73. Okay? So I know that this angle now is 73 degrees. So we have 5.4 over sine 27 equals x over sine 73. Well, how do we solve proportions? We cross multiply and then solve for whatever the missing item is. So when I cross multiply, I get x sine 27 equals 5.4 sine 73. Divide by sine 27, and there's my answer. So you're just setting up a proportion, cross multiplying, solve for what's missing. So that's like if we're missing a side. What if we're missing an angle? Here's one, solve for x to the nearest degree. In this case, I'm missing the angle. But what do I have? I have a side and an angle opposite. I have a side and an angle opposite. All right, so let's set up our proportion. Again, sides go on top. So 3.8 over the sine of x, 7.2 over the sine of 40. Cross multiply. Okay, I cross multiply, I get 7.2 sine x, 3.8 sine 40. Again, I'm solving for sine x now. So I'm going to divide by 7.2. All right? Now, I have sine x equals, all right, this decimal. We just got done doing this. I'm going to use second sine. Second sine and get an angle. And I believe it said round to the nearest degree. Nearest degree, so 19.8 rounds up to 20 degrees. So in this case, you're going to cross multiply, solve for sine x, and then use second sine to get this angle answer. And so law of sines can be used to find sides and angles by just setting up a proportion, cross multiplying, and then solve for what's missing. That's it.